Today I'm going to talk in more detail about inverse trig functions, inverse sine, cosine, and tangent. First of all, let's talk about the input and the output. The regular y equals sine of x or cosine of x or tangent of x, not the inverse, but just the regular trig functions. They take angles as inputs. Which are the x values, and return real numbers as output. So the input are the x, and the output are the y's, or the real numbers. For example, 1/2 is equal to the sine of pi over 6. All right, the input is the angle. The output is the 1/2, which is just a real number. Okay, so that's just the regular trig functions. Now the inverse trig functions, y equals arc sine of x, or arc cosine of x, or arc tangent of x. Instead of taking angles as inputs and real numbers as outputs, they take real numbers as input, which are the x values, and they return angles as the output. For example, if you have y is equal to, or I'll put a real number in there, or an angle in there, you can say pi over 6 is equal to the arc sine of 1/2. That's just the inverse of what I wrote above. So the real number is the input, or the x, and the angle is what is returned as the output, or the y value. So let's take each one of these, arc, sine, cosine, and tangent, and let's list some characteristics. First of all, let's look at arc sine. We said yesterday that the domain is between -1 and 1. The range is between negative pi over 2 and pi over 2. And the range, the output values, this range, these are angles, and those angles correspond to quadrant 4 and quadrant 1. So these are quadrant 4 and quadrant 1 angles. That's all you're going to get out of an arc sine, is a quadrant 4 or a quadrant 1 angle. So in quadrant 4, you're going to get angles between negative pi over 2 and 0. And in quadrant 1, you're going to get angles between 0 and pi over 2. And that is if your input is negative. This is if the input is negative. The output is going to be a quadrant 4 angle. And right here, if your input is positive, your output is going to be a quadrant 1 angle. The input cannot be less than -1 or greater than +1. All right, so you can't do an arc sine of 3, for example, because there is no angle whose sine is equal to 3. Sines have to be between -1 and +1, so arc sine of 3 doesn't exist. and I'll just put DNE for does not exist. If you ever see me writing DNE, that's what that means, does not exist. Let's talk about composition. If you do an arc sine of the sine of x, we saw in class today that this is equal to x only when the x value, this input, is between negative pi over 2 and pi over 2. So for example, if we do an arc sine of the sine of pi over 4, this is going to be equal to pi over 4 because that input value is between negative pi over 2 and pi over 2, so that holds. But if you do an arc sine of the sine of 3 pi over 4, right, the sine of 3 pi over 4 is still square root of 2 over 2, but the arc sine of the square root of 2 over 2 is equal to pi over 4. So in this case, the input is not equal to the output because this angle that I've given you is outside of this range between negative pi over 2 and pi over 2. But if you do a sine of an arc sine of x, that is always going to be equal to x, but this only will work when x is between negative 1 and 1 because you can't do an arc sine of a number that's less than 1 or greater than, less than negative 1 or greater than positive 1. So this works always. But you have to say x has got to be between negative 1 and 1 because otherwise this value is undefined. All right, so this is always true as long as this value in here is defined. But this is only true up here if your input values are between negative and positive pi over 2. Let's talk about arc cosine. We said yesterday the domain of arc cosine is negative 1 to 1, and the range is 0 to pi. So that means if you have a range of 0 to pi, this means that those angles are from quadrant 1 and quadrant 2. We said that today in class. All right. If your input is negative, if x is negative between negative 1 and 0, then the output is in quadrant 2, which is between pi over 2 and pi. Those are quadrant 2 angles. So if x is negative, we can see that on the graph. When you go to the negative x, your output is up in quadrant 2. But if x is positive, if the input to this is positive, then your output is in quadrant 1, and in quadrant 1 your angles are between 0 and pi over 2. Again, your input, the x values can't be less than negative 1 or greater than 1. Right, that's outside the domain. So you therefore can't do an arc cosine, say, of negative 4. That does not exist. There's no such thing. Okay, let's talk about the composition. If you do an arc cosine of the cosine of x, we did some of these in class, I think. This is always equal to x. The input is always equal to the output, but that is only when that angle is between 0 and pi. So 0 less than or equal to x is less than or equal to pi, so that works. So if you do an arc cosine of the cosine of pi over 3, the cosine of pi over 3 is a half, and the arc cosine of a half is equal to pi over 3. So that works because pi over 3 is in that range. Also, if you do the arc cosine of the cosine of 2 pi over 3, you're going to get 2 pi over 3 because 2 pi over 3 is still in that range. This wouldn't work if it was arc sine though, because 2 pi over 3 would be outside the range for that composition. But if you do an arc cosine of the cosine of, let's say, 4 pi over 3, the quadrant 3 angle, this would be a negative value. So this would evaluate into 2 pi over 3. I'm sorry, yes, 2 pi over 3. Because this value in this set of parentheses is the same thing as this value in here, so the output would be the same. And that's because 2 pi, or 4 pi over 3, the input is outside of this range. All right? And the last thing is if you do a cosine of an arc cosine of x, that's also equal to x. The input is equal to the output, but this only works when x is between -1 and 1, because you can't have an input to an arc cosine that's less than -1 or greater than 1. So that's always true as long as x is between -1 and +1. That's just by definition of the arc cosine. All right, let's do number 3, arc tangent, which is similar to arc sine in some ways. We said yesterday the domain is all real numbers between negative and positive infinity, but the range is between -pi over 2 and pi over 2 exclusive. Don't put square brackets on these because it doesn't include those. Those are the asymptotes, the horizontal asymptotes. So if the input, if x is negative, the output is negative. You can see that from the graph also. And if the x is positive, the output, is positive. All right, so if you have a negative input, the negative input could only be, or the negative output would only be between -pi over 2 and 0. And if the x is positive, the output to that would only be between 0, and it can never be greater than +pi over 2. All right, and let's do composition. Oh, also, if you have a domain of all real numbers, you can put anything into an arc tangent. So you can do arc tangent of any number at all. It can be really big, really small, because the domain is is all real numbers, and that's unlike sine and cosine. All right, so let's do some composition now. We'll talk about the arc tangent of the tangent of x. That's always equal to x, but only when x is between, I'll say, -pi over 2 is less than or equal to x is less than x is less than pi over 2. You can't do an arc tangent of pi over 2, so excluding those. So if you do an arc tan of the tangent of, let's say, pi over 6, you're going to get pi over 6 as the result. But if you do, and this is an example, but if you do an arc tan of the tan of, let's say, 7 pi over 6, that's going to be a negative value. So that would be actually equal to negative pi over 6. So the input does not equal the output because this 7 pi over 6 is outside of this range here. But this input does equal the output because the input is in the range. And you can also say, and this is the last thing we're going to say in our notes for today, that the tangent of the arc tangent of x is always equal to x, and that's for all real numbers. Because you can input anything into an arctan, you're not restricted to between -1 and +1 like you are with an arc sine and arc cosine. You can put anything in here. So whatever the input is, you will get as the output if you have the tangent of the arctangent. And that's it for today. We'll do some exercises tomorrow in class.